Hello, hello. All right. Good morning. Good morning. So we have now the study of chemistry. So this is an audio recording. Medyo pag-uusapan lang natin kung ano ang tungkol sa pag-aaral ng chemistry. So kumpara sa ibang mga subjects, itong chemistry ay pinaniniwalaan na mas mahirap. At least sa introductory level. So, yon. So, merong mga perception na may mga specialized vocabulary daw na ginagamit dito sa subject na to. So, ngunit kung ito yung yung first time mong mag-undergo sa subject na to or mag-aaral ng subject na to or even hindi mo to first time, second time or even for the nth time nag-aaral ka ng chemistry pero hindi mo pa rin nahihirapan, medyo nahihirapan ka pa rin, what I mean. So I believe na meron na rin mga familiarity. Meron na rin you already have more familiarity with the subjects. Kasi naman to you encounter this in your everyday life, even in your everyday conversation. So in everyday conversation we hear the words that have a chemical connection. So like for example, ano ba yung mga words na although itong mga words na ito scientifically nagagamit in a right context, kumbaga so yung electronic, for example, quantum leap, yung equilibrium, yung catalyst, yung chain reaction, critical mass, yung weight. Those are words na minsan nagagamit natin in everyday life na without knowing na din siya, part siya ng study of chemistry, pero minsan nagagamit natin sa sa ibang context or sa ibang meaning, kumbaga. So kung halimbawa nagluluto ka, nagbe-bake ka, gumagawa ka ng sinabawan, sinigang, or nilaga, you are a practicing chemist. So from experience gained in the kitchen, you know that, for example, yung oil at yung water, hindi sila nagmi-mix. So you know that the boiling water left on stove will evaporate. So kung continuous mo siyang pinakuluan, halimbawa ang tubig, it will continuously evaporate until such time na maubos na yung tubig mo doon sa kaldero mo kung pinabayaan mo lang. So that is an application of chemistry. So you apply chemical and physical principles when you use baking soda to leaven bread. Choose a pressure cooker to shorten the time it takes to prepare soup. Add meat tenderizer to a pot roast. Pag nag-squeeze ka ng lemon juice sa sliced pear, yung pears pag in-slice mo, 'di ba, nag-ooxidize siya. Yung nakikita niyo nag-color brown siya. So that is nag-ooxidize siya. So mapiprevent yun kung lalagyan mo siya ng lemon juice. So dito sa Pilipinas, kalamansi ang pwede rin naman yon. So kinokontra niya yung pag-oxidize ng ng na-slice na pears or even apples, yon. So para naman yung halimbawa, 'di ba, pag nagluluto tayo ng isda, para mawala yung lansa niya, anong ginagawa natin? Nilalagyan natin ng kung ano-anong spices such as vinegar, even ginger. So those are spices na meron siyang chemical characteristic na nagda-drown out doon sa sa fishy flavor ng fish. So kung nagpo-poach ka ng egg, so that is another chemical reaction. So every day na every day we observe such changes without thinking na ano na pala yun, chemical reaction. Of course, everything is under chemical, may mga chemical nature. So, of course, under siya sa law of chemistry or the physical laws. So, the purpose of of studying chemistry is to make you think na parang yung pag-iisip mo maging chemist na rin. So, thinking like a chemist, kumbaga. So, to look at the macroscopic world, the things we can see, we can touch, we can measure directly and visualize the particles and events of the microscopic world that we cannot experience without modern technology and imagination. So dito, pag nag-aral ka ng chemistry, so medyo magiging ka na, ang imagination mo na medyo titingin ka na sa mga bagay na parang nakikita mo na yung microscopic level, yung molecules, kung paano nga ba nagre-react ang oxygen sa iron para maging rust. Tapos kung paano nga ba nagre-react for example, ang baking soda at ang acetic acid. So paano sila nag-neutralize. So certain things like that. So medyo fascinating tong field na 'to kasi marami kang matututunan, marami kang mare-realize as you go on. Mga everyday situation na mayroon palang chemistry na nangyayari dito na ngayon alam mo na kung ano yung dahilan, yung reason kung bakit ganito, ganyan. So in other words, chemists often see one thing in the macroscopic world tapos iba ang iniisip nila sa microscopic world. So, ganon. Okay? So, yon. A chemist might think about the basic properties of individual atoms or ion and how these units interact with other atoms and molecules to produce the observed change. Yun. So, okay, sa pag-aaral ng chemistry, syempre meron ka pa rin gagamit ka pa rin ng tinatawag natin na scientific method. Ano nga ba itong scientific method? So, lahat ng sciences, even social sciences, including social sciences, nag-i-employ sila ng variation itong tinatawag na scientific method. So, ano tong scientific method? So, ang scientific method is an approach to research. So, for example, psychologist wants to know kung gaano nakakaapekto ang noise sa ability ng mga tao na to learn chemistry. Ganon, isang yon, may magagamit ka ng scientific approach doon. Tapos kung gusto malaman ng isang chemist, interesado siyang malaman yung heat na rini-release ng isang hydrogen gas. Okay? When hydrogen gas burns in air, tapos gusto niyang malaman kung okay, paano mag-react ang isang chemical sa another chemical. Yun. So, ganun lang yun. So, the first step in scientific method is to carefully define the problem. So, syempre, yun ang una nating kailangang define yung problem. Kasi, without sabi ka nga, without knowing the problem, paano mo isosolve kung hindi mo naman alam yung problem? So, knowing the problem, understanding the problem, makes the problem half solved, sabi ika nga. So the next step includes performing experiments, so making careful observations and recording information or data about the system. So the part of the universe that is under investigation. So ang next na ang gagawin mo is magpe-perform ka ng experiment. So magde-design ka ng experiment base sa sa problem mo. So by through experiment, okay, through observation or maybe through experimentation, so magkakaroon ka ng ng analysis ng data. I-record mo yung information, and that data, pag in-interpret mo na siya, it will be useful sa pag-draw ng solution sa isang problem. So the part of the universe that is under investigation. So in the examples just discussed, the system are the group of people. For example, doon sa psychology, so mayroong mga grupo ng tao, may mga isa-subject ka sa noise, may mga isa-subject ka sa yung may control group ka na hindi subjected sa noise. So parang ganun din ang sa chemistry. Magkakaroon ka ng controlled and magkakaroon ka ng yung hindi controlled group. So the data obtained in research study may be qualitative, consisting of general observations about the system, mga general observation. Tapos meron naman yung quantitative na comprising numbers obtained by various measurements of the system. So chemists generally use standardized symbols and equations in recording their measurements and observations. So ayun, may mga nomenclature, may mga shortcut method na ginagamit ang mga chemist kung mag-aaral pa tayo ng pagpupursue pa tayo ng pag-aaral ng chemistry, doon malalaman natin kung ano yung mga shortcut method ng sulat ng mga chemical formulas. Tapos these forms are representation not only simplifies the process of keeping records, but also provides a common basis for communication with other chemists. So itong mga nomenclature na to, yung way of writing chemical formula, may it be empirical or structural, yung geometric structure, standardized to. So that kung magsusulat ka nito or ilalagay mo to sa papel, pag binasa siya ng another chemist or another scientist who is interested in your study, for example, meron kang research, then wala ka na, namatay ka na, then yung research mo na maiiwan dito sa mundo ay pwede pa siyang ipagpatuloy ng ibang chemist or ibang researcher that is interested in your field of research, and maiintindihan niya yung mga sinulat mong nomenclature, yung mga sinulat mong mga symbols, kasi yun ay standardized. That follows yung sinet na standard ng International Union of Pure and Applied Chemistry. So this form of representation not only simplify the process of keeping records, but also provides a common basis for communication with other chemists. So when the experiments have been completed and the data have been recorded, the next step in the scientific method is interpretation. So ito na nga, yung sinabi ko kanina, i-interpret na yung data. So meaning that the scientist attempts to explain yung na-observe niyang phenomenon kung ito yung nangyari. Bakit ito nangyari? So magbibigay siya ng explanation. So mag-isip siya ng dahilan. Ito, ganyan. And so on and so forth. Base sa mga na-observe niya na phenomenon na nangyari. So, okay, based on the data that were gathered, the researcher formulates a hypothesis. Ano ba ang hypothesis? Ito ay isang tentative explanation for a set of observations. tentative explanation. So hindi pa siya final. Like nagbibigay ka lang ng dahilan kung bakit nangyari yon. Then further experiments are devised to test the validity of a hypothesis. So for example, yung sliced apple, for example, ay nagiging brown. So magse-set ka ng ng experiment kung ano yung kung kung bakit siya nagiging brown, kung bakit siya, for example, di pa natin alam yung concept of oxidation, ganon. Hindi mo pa alam kung anong nangyayari doon sa sliced apple na yun. So, yun. Tapos, paano ba ito mapiprevent? Mga ganong concept. Paano ito mapiprevent ito pag naglagay ka ng letter A, vinegar, ganon. Letter B ng lemon. Letter C ng baking soda, ganon. Parang magbibigay ka lang ng tentative solution to the problem, and then i-observe mo kung anong nangyayari tapos kung ano ang result doon. Then so after a large amount of data has been collected, it is often desirable to summarize the information in a concise way as a law. So after noon, siyempre magkakaroon ka na ng data, mo na yun, i-summarize mo na yun into information. So, yung law, ano nga ba ang law sa konsepto ng science? Yung law is a concise verbal or mathematical statement of a relationship between phenomena that is always the same under the same conditions. So, ibig sabihin magbago-bago man ang mundo, pwede ba yun mangyari? So anyway, magbago-bago man ang takbo ng mundo, yung law na yun, that is the same. Kumbaga, for example, Sir Isaac Newton, second law of motion, so which you may remember na force equals to mass times acceleration, F equals ma. So what this law means is that an increase in the mass or in the acceleration of an object will always increase its force proportionally, and a decrease in a mass or acceleration will always decrease the force. So that statement is true kahit anong mangyari. Kahit magbago man ang presidente ng Pilipinas, kahit magbago man ang presidente ng Amerika, that law is the same. So, okay. Yun. So unless na magkaroon ng another law na magna-nullify dito sa current law na ito. So hypotheses that survive many experimental tests of their validity may evolve into theory. So, siyempre, yung hypothesis, tinitest yun. So, pag tinest yun, tapos paulit-ulit siyang nakasurvive doon sa experimental test, eventually, pwede na siyang gawing theory. So, theory is a unifying principle that explains a body of facts and or those laws that are based on them. So, unifying principle na siya that explains the body of facts. So, theories are constantly being tested. So, if a theory is disproved by experiment, then it must be disregarded or modified so that it becomes consistent with experimental observation. So, proving or disproving a theory can take years, even centuries, in part because the necessary technology. So, pag minsan may mga theory na hindi pa pwedeng matest or hindi kayang itest dahil wala pa yung kinakailangan na technology, hindi pa na-discover o hindi pa na-iimbento. So, mag-aantay hanggang sa kung ma-discover yon. So, pwedeng hindi pa yun ma-discover in the next century or next 2 centuries. Then, that theory will remain a theory. Okay. So, atomic theory na madidiscuss natin sa iba pang mga next pang mga usapin ay isang example. So, It took more than 2,000 years para to work out this fundamental principle of chemistry proposed by Democritus. Si Democritus pa talaga ang nag-conceptualize nitong atomic theory. Isa siyang ancient Greek philosopher. A more contemporary example is the Big Bang theory of the origin of the universe. So, isa pang example ng theory to, Big Bang theory. So, scientific progress is seldom, if ever, made in a rigid step-by-step fashion. So, wala naman talagang way ng ng scientific progress. So, minsan nauuna yung theory, minsan nauuna yung law, minsan nauuna yung hypothesis. It depends kung ano ang maunang maisip. Then, nagkakaroon na lang ng experimentation just to prove kung talagang totoo or valid yung hypothesis or theory or yung law na yun. So, two scientists may start working on a project with exactly the same objective. Pero yung kinalabasan pwedeng iba. Yun. So, pwedeng iba yung way ng approach nila ng pag-experiment. So scientists are after all human beings. Since human being ang mga scientists, nagkakaroon sila ng iba't ibang modes of thinking and working. Ang iba mabilis, ang iba mabagal, ang iba ang perspective, ang iba taliwa sa perspective ng isa. So iba-iba sila. So nagkakaroon din ng iba-ibang approach. So okay, depende din yun sa background, sa training, sa personality, sa kung saan sila nag-aral, kung paano nila inaral yun, yung approach din ng pagturo sa kanila. Ganun, kaya hindi siya the same, nagkakaiba-iba siya. So, the development of science has been irregular and sometimes even illogical. So, great discoveries are usually the result of cumulative contributions and experience of many workers. So, even though the credit of formulating a theory or a law is usually given in only one individual. So, minsan may mga theory na kumbaga sabay-sabay na naisip ng iba't ibang individual, even though independently silang nagtatrabaho on that same concept, pero they arrive on the same theory. So may mga ganun na instances. So there is, of course, an element of luck involved in scientific discoveries, but it has been said that chance favors the prepared mind. So it takes an alert and well-trained person to recognize the significance ng isang accidental discovery and to take full advantage of it. So one example of that accidental discovery is the accidental discovery of penicillin by Alexander Fleming. Si Alexander Fleming, hindi naman niya talaga objective na ma-discover yung penicillin or the penicillium. So, but through accident, na-discover niya yun. So, that is luck. So, more often than not, the public learns only of spectacular scientific breakthroughs. From every success story, however, there are hundreds of cases in which scientists have spent years working on projects that ultimately led to a dead end. So, meron din mga study na minsan, wala na talagang patutunguhan. So, ganoon talaga. So, nevertheless, if these dead ends lead to a dead end, still this is a discovery kasi for the future researcher, since mababasa nila yung mga ganong study na pala to, wala na tong patutunguhan. So, hindi na natin gagawin tong approach nito. So, kumbaga mababawasan na yung effort na gagawin nila sa pag-discover. So, hindi na nila gagawin yung ginawa ng mga naunang napunta sa isang dead end. So, in the end, it is still a discovery. It is still a contribution to the scientific progress. Ano pa ba? In which positive achievements came only after many wrong turns. So, ito na nga yun. So, minsan, yung dead end na yun, nagko-contribute nga continually sa growing body of knowledge about physical universe. Okay, it is the love of search that keeps many scientists in the laboratory. So, kung talagang gusto mong mag-discover, mag-investigate, then you will keep on researching. Okay.